Welcome everyone. In today's episode, we will be discussing about the application modernization with AWS. So this will be a show specifically focusing on discussion about the modernization, how organizations can start with the modernization into cloud. So before we start this episode, I want to give a quick disclaimer that all the opinions that I expressed through this podcast are purely personal and do not represent any of my employers' view in any way. So this podcast will be available on all leading podcast platforms. And thanks everyone for listening and tuning into Coding Talks. So organizations who have a lot of organizations or enterprises who have a lot of legacy system, they face a lot of challenges, especially challenges with having legacy monolithic applications and shared databases. So how challenges happens in such organizations is that whenever they want to work on a monolithic application with a shared database, especially with a lot of development teams, say for example 30 plus or 40 plus development teams. I'm talking about the large scale organization. Even if it's more than 10 plus development teams, still there will be challenges working with monolithic applications. Not just for the development teams, there will be issues with who own a specific set of functionality. That will be another challenge. Then during the testing, it will create bottlenecks. In addition to that, it will significantly increase the development effort for the teams, because everyone will be working towards a shared database or a shared systems. Definitely their cognitive load will be heavy and they face significant friction in making the changes because one code base will be depending on another teams. So these are some of the problems with the legacy systems. So you won't get the full advantages of the flexibility working in such a monolithic database or a shared database system. And most of the enterprises have a lot of such legacy systems, and this episode discussion is about how to start modernizing those systems using AWS cloud native architecture. So we are not going deep into the architectures or about the specific services in AWS. Already there are a lot of episodes that will be covering those things. We will understand from a layman perspective how an organization can start this modernization journey, and along with that some of the benefits that gets through this modernization. We will also discuss some of the services in AWS that can help with that by taking a few examples of the organization who already done with this migration or modernization, and some of the return of investment. So whenever we modernize an monolithic application to modular cloud native architecture, definitely there will be a return of investment in that. So that part also we will be discussing, and we wind up the episode by discussing on some of the experts' insights into this area, modernizing the architecture. So by end of this episode, you will have a clear understanding about what kind of architecture or modernization you will be aiming for. So this is based on the latest trend, the current trend in modernizing applications using AWS Even though this is an AWS focused session, this will be equally applicable for every other cloud provider as well. So this modernization, when I say modernization, it is not just a technology migration from the monolithic system to a kind of a cloud native system, but it's a kind of a shift of a organizational and its cultural evolution as well. So along with this modernization, organization structure also might change based on this, and also there will be a shift in the way of the process by which an organization encounter when they move into the cloud native. So there will be a lot of changes that can expect in that. So, and it has its benefits as well. So we can start looking into the modernization journey. So the modernization is basically built on three principles, mainly three principles. One is the business domain ownership with empowered teams. So if you have a monolithic code base in an organization, the first task is to evolve that into a domain based model with specific teams having ownership of that domain. So this is a fundamental shift, means rather than having every team is focused on a single code base, now the code base is modernized into a modular domain based structure with dedicated teams having ownership of those domains. This will bring more flexibility to the teams to work on that without depending on other teams. For that, there is a clear definition of the business domain that needs to be there when we modernize. Second thing is, once we have this domain, we will be modernizing that domains from their existing code to a modernized structure with the AWS Serverless first strategy. And then finally, we will connect all those through the event-driven architecture, which offers a kind of a SaaS scale resilience. So once having these three principles, like the first one is the business ownership with empowered teams. Second one is the flexible evolution through serverless first strategies. And third one is SaaS scale resilience through event-driven architecture, which is connecting everything through an event. So we will discuss more about this as we go deep into the episode. But these three are the key principles. So once an organization have these in place, the benefit they are getting is like increased deployment velocity. Previously, the deployment velocity will be very less. Then once have this in place, organization gets resilient, observable, cost efficient systems that scale with the business growth. The challenge with the legacy systems is that it won't scale well with the business growth. So having a modular, resilient, observable system helps with the scalable with the business growth. To achieve this modernization, AWS offers a comprehensive set of tools. So these tools can be help to modernize your architecture or code base from monolith into a newer cloud native approach. Some of the services that we will be discussing in this episode are AWS Lambda. Lambda is for compute. If you want to have a compute requirements, you can have Lambda without too much bothering about the infrastructure considerations and all. the infrastructure challenges, how to scale those infrastructure, that all will be handled by the AWS itself. They do the heavy lifting of that. Your focus as an organization will be to focus on the business logic uh, for a specific domain using this serverless services. So Lambda is on such service, and similarly, when you want to have a scalable database, you can use DynamoDB, which is another serverless kind of database. Then connecting different events, connecting different domains, serverless events and all. There is a service in AWS called Amazon Event Bridge, which is used for event routing. And whenever there is a need for having complex workflows which required for your organization, definitely every organization will have its associated workflow. So modular functions can be used for creating individual workflows, and when you want an orchestration with these workflows, you can use AWS step functions for the orchestration of these different individual workflows. So this evolving architecture which we are discussing currently is a kind of a serverless based architecture which reduces the operational burden while providing automatic scaling. It has built-in resilience because AWS manages the infrastructure and resilience. You don't have to worry about all those things. And it's a economics model in the sense that you will be pay only for what you actually use. So in this way, you can modernize and monolithic applications to domain-based serverless architecture using all these services. And in addition to that, AWS also offers a agentic IDE which is called a Q developer, which we already discussed in most of the other episodes as well. AWS Q enhances your development experience with its AI powered assistance. It can help with your cloud native architecture design, automatic suggesting the optimal service configurations once you modernize your architectures, and it can identify architectural anti-patterns. So definitely when you modernize an architecture, there will be a lot of issues that can happen with architecture. It's an architecture means an evolving one. So usually there will be a lot of anti-patterns that can occur, and Amazon Q can help to identify those. The benefit of Amazon Q is that you will get Amazon Q as a kind of an integrated chat ID within your Visual Studio Code, so that the development teams can use that. Similar time that can also be used inside your AWS console as well, whereby you will get quick insights about the different existing the anti-patterns that exist within your accounts. It can provide intelligent recommendations for serverless implementations that balance the cost, and it also makes the operation more simple. So a lot of enhancements are coming up for Amazon Q. So try to use that service. So if you have already using any kind of an ID, especially VS Code, already there is an integration. You just have to have a AWS account, and then you can it is called AWS Builder ID. You can create one for free, and then you can connect to the Amazon Q. So by default, Amazon Q offers a kind of a chat interface where you can ask anything about the AWS architecture. You can get the guidelines. You can provide a blueprint of the architecture and get optimized recommendations. It's a great tool for learning. You can chat with that and learn, and just with the Amazon Q alone. So other than ID, it is also available as a kind of a CLI tool where you can install on your system and connect with your builder ID and can chat with. So with the free account, there is a limit, but you can still use a lot of things with that. Then, yeah, this along with the AWS, we were discussing about the ways by which we were modernizing the architecture. So the some of the services which we were quickly discussed, like Amazon Lambda, AWS Lambda, step functions, and so on. Now the importance of building domain driven architecture is what we are going to discuss now, because that's the first step which we will be doing. Identify the domains that are required for your organization. Once you split your domain, once you break your monolith code into the different domain, the advantage that your organization would be getting is to assign those domains to specific individuals who can own it by themselves, and they can work the maximum on that with whatever tools they are familiar with. There can be the technology flexibility, the development language flexibility. You can choose any language as you like. So individual terms and individual uh, uh, teams can work in that fashion with this approach, domain driven architecture approach. So that's why the first principle, building around the domain driven architecture, is important, because what happens is usually organizations stuck with this monolithic code base experts a kind of a inertia or a stuck state where they cannot further evolve from that. Everything they will be doing is on to that monolith code base itself, and as the code base becomes more and more, there will be a lot of challenges, as we discussed before. So based on the first step is like based on the business objectives, uh, the teams will get a clarity, and then they will structure the code into different business domains. So there are different domain driven architectural patterns that are available, and based on that, clear domains are identified, and each domain will be assigned to a different AWS account, or maybe multiple domains can be owned by different teams as well. That's fine, but mainly the domain driven architecture patterns are identified, and then the AWS account ownership models ensure that specific teams own both the code and the operational responsibility. So an organization have different accounts within the AWS, and each account holds specific domains and their resources. The full responsibility of that domain will be owned by a specific team, and entirely all these accounts can be grouped together using a service in AWS which is called AWS Organization, so that it finally wraps everything into a single organization as well. But each domain will be working under a different account as well. So this kind of a flexible evolution with a clearly defined the domain boundaries actually decouple the dependencies. And once you have this different domains decided, then AWS offers several serverless tools, as we discussed before. This allows the system components to evolve independently in different domains without depending on other domains, thus creates its own stability. So this is the way by which which an organization evolved from a monolithic code base into a kind of a modern domain driven serverless architecture. And this is not just about in theory, it's about it's fully practical, and how this is practical is lot of organizations are also already transformed this through this, and we will be discussing some of those organizations, because that will help you to get a confidence like everyone can evolve, every organizations can evolve in this way. So taking a lot of examples are there. I am considering some of the examples from which are provided in AWS case studies. One of that is the Capital One, which is a financial service. They originally had their code in monolithic banking platform. That original monolithic code had its own problems, as some of them are we already discussed. There will be much more than that, a lot of challenges with the monolithic code base. So they want to modernize, and they already modernized into the cloud native architecture using different serverless tools like AWS Lambda, Amazon API Gateway, and Amazon DynamoDB. So AWS Lambda, as we discussed, it's a kind of a serverless compute model where you can just focus on creating your code and you don't have to bother about the infrastructure. You as a developer just focus on specify how much CPU and how much memory, how much compute and how much memory you can consume, and then AWS Lambda will be you can do a specific task in AWS Lambda. You can write that code, and whenever the code is required, it will be working based on a trigger. So this is the benefit of having event driven architectures, where you can have individual functionality developed using AWS Lambda, and then using services like Event Bridge, we can connect different events so that this specific task will be then executed. So this execution will be on the fly. AWS handles that for you. You just have to wire a trigger, and based on the trigger input, input can be many kinds of inputs like HTTP trigger, queue based trigger, or if you want something else like if you when you upload something onto the S3, which is an object storage in AWS, based on that you want to have some functionality to execute, then that is possible with AWS Lambda. And not just for this event, you can have also have complex workflows. So most of the organizations have a complex workflow, like there will be a payment initiating first, then it will go through a series steps of approval and so on, and then finally there will be another set of services will be executing. So this kind of complex workflow scenarios every organizations will have, and with the help of AWS Lambda and another service which is called AWS Step Function, we can orchestrate all this. There are different orchestration patterns as well. Then the Amazon API provides a kind of an API endpoint for these Lambda, so that if your website or some other APIs or some other clients want to call an API and want to execute these Lambdas, it can be done from behind this Amazon API gateway. And not only Lambda, Amazon API can be connected to other serverless services as well. There are a lot of serverless services within the AWS, the S3, DynamoDB, a lot of other services are there, including AI services itself. So by implementing this kind of a domain-driven design, as we discussed, this offers the flexibility for the teams to work within the domain without depending on other teams, and this reduces the deployment lead time from weeks to hours by supporting around 10x transaction volume growth. So this 10x transaction, this is based on a metrics that is available from some of the organization. So this can vary, but mainly you can achieve up to 10x plus transaction volume growth. Previously, by working when teams were working on to monolith code base, it would take weeks or maybe months to deploy a feature, while when teams own specific domains and have the flexibility to work on those domains, they could deploy a feature in a few hours without depending. And also the serverless is suitable for the POC kind of application, where you can quickly spin up an application with a feature, because you can just focus on that actual logic instead of thinking too much about the infrastructure and so on. So serverless is a great tool for POC and research as well. So we were discussing about one of the organization called Capital One. Similarly, Netflix, one of the popular media streaming service, they were using AWS Lambda, AWS Kinesis, and Amazon Event Bridge to build a globally distributed event-driven architecture supporting over 200 million subscribers. So they are entirely cloud native, and they process around billions of events while maintaining around 99.9% availability. And also this serverless architecture, one of the benefit with serverless architecture is that it scales automatically, and this scalability helps Netflix to handle traffic spikes, especially during their major content releases. And this can help them to optimize the price as well, and only during that spike period they have to pay the extra price. So it's kind of a pay as per use pricing model. Then another one example we could consider for this modernization journey from the monolith code base to a modernization approach is Coca-Cola. They are using their a kind of an event driven microservice approach using AWS Lambda, DynamoDB, and AWS Step Functions. As per their metrics, they have achieved around 50% faster feature delivery while reducing their infrastructure cost by around 40%. Also, because each teams own their own domain, and this is a kind of a multi-account strategy, and Coca-Cola have a global teams, and having this multi-account strategy enabled the Coca-Cola to develop independently while maintaining consistent security and governance standards. Then similarly for in healthcare, Philips Healthcare, they were having their cloud native medical imaging platform using AWS serverless services while also maintaining this compliance, HIPAA compliance as well. This we discussed in previous episode as well, like these services from AWS is an outcome of their evolution from whatever they have learned from these past years, and AWS require these kind of serverless services to scale because they are handling billions of events per day, maybe trillions of events as well. So this, because of that, they want to have this kind of a scalable event based services more than anyone in a cost effective way. So they are actually kind of outsourcing, we could say, like an outsourcing these things in the form of services where organizations can use and get benefit from. So to make the other organization compliance requirements, they have had a few of their compliance solutions as well along with that. So their services have met with their these compliance requirements, and HIPAA is on such compliance. In this way, organizations who have strict regulations or compliance requirements can use AWS services. Also, we were discussing about the Philips. So there in the Philips, they were having AWS Lambda for this image processing, and Amazon S3 for their secure storage, and for workflow orchestration they were using the Amazon Event Bridge. And the benefits Philips gets from this kind of a modernized architecture is they can scale globally, and at the same time the time to market for new diagnostic feature is reduced by 60% while maintaining the highest security standards for the patient data. So these were some of the organizations who are already transformed their monolithic code base to modern cloud native architectures. During the discussion, we understood that they were using a certain set of services. Now, in the rest part of the episode, we can focus specifically on this core AWS cloud native serverless services, which can help with this transformation journey, so that you will get a more picture about these services in depth. In addition to that, you can check the AWS documentation for this as well. So we are going to look into some of an overview of these different services from their compute, from different categories like compute, storage, and so on. So more details we can get from the documentation. You can go through that and learn more about that. So coming to the serverless compute and orchestration, AWS Lambda is the main service which AWS provides. Lambda provides around event-driven serverless computes that scales automatically from 0 to thousands in concurrent execution within a minute. So this means that when you execute a Lambda based on the input, it can scale. So within 1 minute, it can spin up around thousands of concurrent executions. So how many executions you want to have, how much memory you want to consume for that, you can all define while defining the Lambda. You can define the Lambda manually using the AWS console. That is one approach, and then you can upload the code from different languages, developed using different languages. So you can have .NET C#, .NET, the .NET Core, then Python, PHP, and so on. A lot of codes are supported. Exact details about the supported languages are available from Amazon documentation. Same way, you can also spin up the AWS Lambda using an infrastructure as a code base, which is the recommended approach. The flexibility of that is you can have your infrastructure AWS Lambda as a source code, so that you can incrementally update the AWS Lambda, and also you can scale up and scale down as you can. And whenever you don't require that Lambda, actually Lambda is a kind of a pay as per use service. So you will be paying for Lambda only when it gets executed. You're paying for when it gets executed. The exception to this is the provisioned Lambda, where you have a dedicated Lambda for your specific use cases, especially if you want to have an always on kind of a Lambda usage in specific scenarios, especially in ultra low latency situations. You can have a provisioned approach. So AWS is trying to optimize the AWS Lambda in such a way that this cold start can be reduced. Cold start is a condition where you can think of it like your Lambda, you define a Lambda, and in the initial execution of the Lambda, it will take some seconds of time to get it started. It's a few seconds within that Lambda gets spin up, so that is called the cold start. Once Lambda gets started, gets into a warm condition where then further executions will be handled immediately. For the initial time, a few seconds delay will be there, but that is a kind of a trivial seconds which most of your applications can ignore. That milliseconds of latency So in serverless systems, they mitigate this by introducing queues or some kind of topics in between, so that whenever a request comes in, it passes to the Lambda through a queue, so that the queue will store those events as a kind of a buffer, and then whenever the Lambda is ready to execute, it will execute it. And when there are 1,000 events in the queue, and if you connected your Lambda to that, Lambda AWS will automatically spin up the scale from one instance to 1,000 instance. So if you have 100 items in your queue or 1,000 items in your AWS SQS queue, which is configured to a Lambda, the initial request will take some time for the Lambda to spin, and once the Lambda is spin up, within 1 minute it can spin up to around 1,000 invocations. So that means parallelly executing these 1,000 invocations at a time, based on the amount of memory you have configured for Lambda. So this provides a kind of a 0 to thousands of concurrent executions, where you will get the benefit of parallel executions. Together with that, the AWS also offers AWS step functions for this workflow orchestration. So that means that teams can build complex, resilient applications without managing infrastructure. So next one is like this Lambda, this business logic you have in Lambda. You can connect a service called Amazon API Gateway, which connects and enables secure, scalable API management. And this API Gateway have their built-in throttling, caching, and monitoring capabilities. So that way, you can achieve APIs, create APIs that connects to these business logics with these much of extra features like built-in throttling, caching, and monitoring capabilities. Then you can have a series of Lambda and workflows with AWS step functions. But at the same time, AWS provides another service which is called event-driven architecture services. So EventBridge falls under that category. It's kind of a central nervous system, we can call, for the event-driven architecture. And the main benefits having an event bridge in between is this enables kind of a less a coupling between these services through managed event routing. Also for streaming cases, there is another service which Amazon provides, which is the Amazon Kinesis. Also Amazon SQS is available, and SNS also. SQS is actually a queue based service, Amazon symbol queue based service. It can store the events, and it can deliver the events in first out order. So there is a FIFO queue also available from SQS. So to clarify this, Amazon has two types of SQS. One is Amazon FIFO SQS, which preserve the order. So if you want to deliver the events in order of its arrival, you can have the Amazon SQS FIFO, while the Amazon symbol SQS service provides more scalable and more throughput performance, but it doesn't preserve the order. It will simply distribute the events to whatever services it's connected to. Similarly, the SNS symbol notification services handles reliable message queuing and notification distribution across the distributed systems. SNS handles the notification distribution across the different systems. So in a real world scenario, you have a mix of all these things. To illustrate this simple flow, if you have an S3 where you are storing the object, and if you want to have some kind of an event connected from S3 to SQS queue, and then it should be processed by a Lambda, you can connect that through an event bridge. So from the S3 it is connected through the event bridge, which will route to specific queues, and from the queue a lambda can be connected. So this means that whenever whenever a new object is there in the S3, automatically that gets distributed through the event bridge and finally to the SQS, and then lambda will handle that on behalf of you. And what happens when 100 objects will be fall down to the S3? At the same, when 100 objects are created or updated on the S3, 100 events will be passed through the event bridge. So event bridge is also a serverless service, and it can scale up to the demands. And then Netflix is using this event bridge, so it will pass through the event bridge, and finally it will reach into the SQS queue, where it will act like a buffer, and then based on the number of items in the SQS, AWS will automatically initiate a different lambda based on that. So this is the advantage of having a serverless system, where if you connect properly to the queue, the different instances will be automatically spun up by the AWS itself. And also it offers inbuilt monitoring as well, so that whatever happening on all these systems are have inbuilt monitoring capabilities connected to AWS CloudWatch, where you will have a consolidated view of all these services from there. You can have the logs, metrics, specific custom loggings, whatever you can have from these systems. And then everything will be consolidated, and you can set monitoring alerts and triggers. Then looking into another set of service, which is for data and storage, S3 is one of the well-known service. In fact, S3 is one of the first service that is launched by Amazon, and when the S3 becomes popular, a lot of organizations need some additional integrations, and that's how now you can see almost most of the services somehow have an integration with the S3. Especially if you look into the generative AI services, you can find it's somehow connected to the S3, because S3 is one of the service which offers unlimited scaling, and it can store any types of amount as you like. It can be used also as a data lake as well. So different kinds of data transformation services, the generative AI services, all actually connects to the S3 in a way. And also S3 has its own features. If you look into S3, it offers a lot of features, and when it comes to because we are discussing about the serverless systems modernization and all, the optimization, cost optimization is one of the needs of most of the organization when they want to do a migration or a modernization. Actually migration, even though I have mentioned migration occasionally, modernization is the accurate word actually. So when it comes to modernization, the S3 offers a feature which is called the multiple storage classes. You can choose the different storage classes based on the application requirements. In addition to that, S3 also offers a kind of a intelligent tier, which automatically sets the storage class based on the usage pattern. This will be beneficial for identifying the optimal usage of S3, especially when it comes to cost optimization. Similarly, if organizations has a lot of requirements for mobile and web applications and their APIs, AWS AppSync offers real-time data synchronization through the GraphQL APIs. Then the next discussion we are going to have, next part of the discussion is about so we have understood the need for modernization, why organization, how to start modernizing, and what are the benefits they are getting. So lot of benefits we discussed throughout the episode, but the short, if you want to have a quick overview of the main benefits, it's mainly about having modular domain driven teams which own independent features, its responsibility, so that it can improve the deployment velocity. This is also the benefit of the microservice architecture as well. Having modular architecture, small modular teams helps in ownership, clear clear ownership of that service. Plus, it offers independent scalability, flexibility for development, less overhead for teams because they don't have to depend on other teams, and it also offers the deployment as well. So such way, when it combines with the serverless, it offers the fastest form of deployment as well. So now we also discussed about some of the services in AWS. So if you check out the AWS documentation, or if you search in about serverless services in AWS, you can find a lot like S3, EventBridge and so on. Some of the core services which are used throughout the AWS, which we are also discussed in this episode. Now to start this journey, you don't have to always break your monolith into smaller microservice or domain based services. It will be difficult for all the organizations to follow that approach. If you can follow that approach, it will be easier. So the recommended strategy is like for newer services that you want to develop within the AWS infrastructure, always go for serverless, or if serverless is not feasible. Some of the times serverless may not be feasible. You can check out the AWS serverless go to serverless events which recently happened in Bangalore and other places as well. So serverless is actually a good choice, and AWS is also moving towards a serverless event, but a serverless form of a architecture. But sometimes serverless may not be suitable for all organization due to certain factors, like they need some considerations they have specific dependencies and so on, where the lambda may not be a best fit, and they want to have custom requirements for specified requirements, or they have a predefined usage where it would be best to go on with the kind of a container or an EC2 model. In those cases, serverless may not be a best fit, but most of the time serverless can be a best fit for most of the organization. So still, even if one organization can't go ahead with that approach as we discussed in today's episode, still there are other ways as well, like AWS offers multiple migration pathways. One is the lift and shift using Amazon EC2 to gradual modernization using AWS Lambda and managed services. So the idea is like you have your legacy systems in some form of an organizational on-premise VM or somewhere where you can lift entirely from there and move that into an Amazon EC2. Where you will get a start to the cloud native architecture, and then you can use a kind of a pattern called a triangular fig pattern, where you identify the business domains one by one and gradually moving that into AWS Lambda and managed services, finally entirely eradicating this Amazon EC2. If everything else is okay, like if we are good to go with entirely with the serverless approach, if it is feasible. Also the AWS well architected framework, which is a kind of a guidance framework provided by AWS, which provides a detailed guidance around building secure, reliable, efficient and cost effective cloud native systems. So you start first with the team identification and team alignment. identify the boundaries, then implement AWS account boundaries for clear ownership. Then begin slowly extract the monolith application and move that into serverless services or container services. But if you are starting with a new service, try experimenting with serverless services to see whether that's a good fit. The benefit is that you reduce the infrastructure dependency and increases the scalability and resilience. Then to help with this modernization, AWS offers another set of services which is called AWS Application Migration Service and AWS Database Migration Service. These services facilitate gradual migration strategies that minimizes business disruption. And along with that, the teams who are working on this also needs to have some understanding about the how to work with AWS services and all. So AWS have its comprehensive training and certifications. In addition to that, they have specialized courses available on our AWS Skill Builder and lot of other events which are available in YouTube and other platforms. The Twitch is another Twitch, Twitch platform offers a lot of training materials as well. You can check out that. So I think we are coming to the end of this episode. So what's the return of investment that organization gets from this modernization journey? So this is not a fixed figure, but based on an average study, it could see like a organization typically see 20 to 40% cost reduction through serverless adoption, especially because they are eliminating the idle resource cost. In the serverless, you are paying only for what you actually use and only during that actual usage. So in fact, you are in reality you are eliminating the idle resource costs and reduce the operational overhead. Also, the pay-per-use model aligns the costs directly with the business value, enabling more predictable budgeting and cost allocation. Also, you can also benefit from the provisioned concurrency which is available for AWS Lambda and EC2. So if you have a predictable performance, you can use that AWS Lambda provisioned concurrency, and also different AWS savings plans for committed usage discounts. Then then for some of the use cases, we haven't discussed that in this episode, but I have discussed that already in different other episodes as well. In addition to the services we have discussed, AWS also offers some of the ways by which you can connect your on-premise systems to the AWS infrastructure. That is worth to discuss a bit in today's episode as well. Reason for that is when organization embarks on a journey to cloud native, they may not able to immediately go to the cloud because of compliance and regulatory requirements. So most of the time, or for some organization, they want to have their own on-premise infrastructure and they have their applications there, and they want to shift some of the parts of that application onto AWS cloud. So AWS also, for such users, for such organizations, AWS offers some of the services like AWS Direct Connect, AWS VPN, Amazon API Gateway, where their existing on-premise systems can connect to AWS through these all different services, either through the Amazon API Gateway or Direct Connect or AWS VPN. This is a kind of a these are services which supports hybrid architectures. And similarly, in case where organization wants to have their own dedicated AWS infrastructure, within their local on-premise infrastructure, they can have AWS outposts, which is a kind of a local version of AWS installed on the on-premises deployment. And also AWS also offers AWS local zones for edge computing requirements. So in addition to this, once you have a presence in AWS, you can have integrations including popular development tools, monitoring platforms, and other enterprise level softwares through AWS Marketplace, which offers an extension from the AWS itself. AWS already offers a lot of services, around 200 plus services for your different requirement needs. In addition to that, they also offer some of the partner solutions which are available through AWS Marketplace. So this is a kind of a flexibility that enables the gradual migration strategies while maintaining the existing tool investments. And also AWS also embraces the open standards like Open API for API specification, Open Telemetry for observability, and the cloud events for event formatting. Also the serverless services which we discussed supports popular programming languages and framework, enabling teams to leverage existing skills while adopting cloud native platforms. So what's next from this? So AWS is actually heavily investing in serverless and cloud native capabilities. Especially they want to reduce the cold start performance for AWS Lambda, as we discussed before. They are also increasing the integration between the different serverless services and AI, generative AI and agentic AI solutions. Now a lot of services are available within the AWS, which is called the Bedrock Agent Core, where you can have agentic AI systems developed using either AWS Bedrock, or you can have using Strands framework or Springs AI framework. And then through this integration, you can further integrate all that into your development workflow. So a lot of integrations are already available where you can connect from your Lambda to these development workflows, like these different AI services. So AWS actually sees a future where envisions a future where they are seeing serverless becomes the default compute model. The benefit that organization gets from this is the complete infrastructure gets abstracted from application development. It also offers edge computing capabilities, improved real-time processing, and seamless integration between cloud and edge environments. So observability is another key important things you have to consider while modernizing an architecture. Because you are moving to cloud, it means that from the day one you should have the observability services integrated. Observability services includes Amazon CloudWatch, which offers the logs, traces, and event-based logging from different services. You can set alarms on that. In addition to that, distributed tracing is also possible through X-Ray. Then detailed logging about the different activities within the AWS premise based on the IAM user usage. You can have that through the cloud trail, which is another one. So these are the things, and finally we are wrapping this episode. And before we wrap, we will wrap with an understanding about the quick things which we discussed in this episode. So AWS architects always recommend starting with the new features using the serverless services, establishing clear domain boundaries early, and invest in automation and observability. Regular architectural reviews should be done so you should have a regular architecture reviews using the AWS well architected framework, which includes the best practices while maintaining continuous improvement and optimizations. And so begin your cloud native transformation by identifying the clear business domains, establishing AWS account boundaries for team ownership. Start with the new features using AWS Lambda and managed services. If you are using the existing monolith code base, start gradually extracting the functionality from existing monolithic applications. Also use other services, supplementary services like AWS Application Discovery Service or Application Migration Assistant to understand your current application dependencies and plan migration strategies. In addition to that, AWS also offers professional services to design migration services. Then resources and supports are also available through the online AWS Architecture Center, which offers a lot of patterns related to AWS architecture based on different scenarios. Then the serverless application repository, hands-on workshop are also available. And finally, the thing is, like we discussed earlier, this is not a just a technical transformation. It's a kind of an organization evolution that enables agility, scalability and innovation. And for that, AWS offers a lot of serverless and cloud native platforms. So the takeaway from this episode is, first is domain driven splitting of your code base. Second is domain driven ownership. Third is serverless transformation through the AWS serverless service. And finally, having a team autonomy, like your teams can work independently whilst maintaining enterprise control using AWS IAM tools and all. So these are some of the topics or the different things related to the modernization, which I plan to cover in today's episode. Thanks everyone for tuning into this Coding Talks podcast. Have a great day.